Hello, one and all. Root Beer here. I hope you're doing well. I really do. We're looking at question 24 in this video. Question 24, of course, on our grade 8 Gauss paper from 2018. Lynn chooses 4 distinct digits from 1 through 9 and arranges them to form the 24 possible 4-digit numbers. So you'll notice 0 is not included. That way we don't have to worry about leading ones or anything like that. So form 24 possible 4-digit numbers. These 24 numbers are added together, giving the result n. For all possible choices of 4 distinct digits, which is the largest sum of the distinct prime factors of n? Whoa, okay, that's a very interesting phrasing at the end. For all possible, so there's lots of different possible choices for n. We want the largest sum of the distinct prime factors of n. Okay. Alright. So, what can we do? Well, largest sum of distinct prime factors, that's nifty. Definitely different thinking. Okay, how do we make these n's? Rather than, I suppose we could sort of pick a 1, 2, 3, 4, write out all 24 different possible numbers and add them up, but we want to be smarter than that, because there's lots of different ways to choose 4 digits from 1 through 9. Suppose I chose the digits A, B, C, D. I have lots of ways to arrange those as a 4-digit number. You know, A, B, C, D, we can do A, B, D, C. There's going to be lots of them. I'm not going to write them all out right now, but if you are going to write them out, as I always try and caution you to do, try and be methodical. Here I'm moving, worrying about the first digit, then the second digit, then the third and the fourth, and I'm trying to keep things as alphabetical as possible while not repeating earlier things. So, A, B, C, D, then I switch the last two. Then I've exhausted everything that starts A, B, so I'll try A, C before I try A, D. So that's just 6 of the possibilities, and if we think about it, there's going to be 6 that start with A, 6 that start with B, 6 that start with C, and 6 that start with D. But not only that, not only do we divide it nice and evenly into quarters, because basically the idea is each number takes a turn, or each digit takes an equal turn, being the thousandth digit, or the hundredth digit, or the tens digit, or the ones digit. Okay? So, a quarter of the time you'll find A in the thousands block. A quarter of the time you'll find A in the tens digit. Okay? We can exploit this regularity. Sure, we don't know about any given one of these 24 numbers, but we don't actually care. We're trying to add them all up. And if we're trying to add them all up, we might want to add the ones, then the tens, then the hundreds, then the thousands. And if we realize that, well, there's going to be 6 A's in the tens, and 6 B's, and 6 C's, and 6 D's, then it becomes a lot easier and more systematic to add them up. We don't actually have to write them all out. Each one of these numbers, like for example, A, B, D, C, is really 1000A plus 100B plus 10D plus C. We just don't usually write this part out when we write decimal digits. But if we add them all up, how many numbers are going to be in the thousands block? Well, you'll get 6 A's, you'll get 6 B's, 6 C's, and 6 D's. Okay, of the 24 numbers, how many hundreds digits am I going to get? Well, 6 times out of the 24, A will be in the hundreds block. And so we get this nice sort of repeating pattern. Finally down to the ones block. I guess we can write times 1 there. And so there's this very nice regularity. Okay, well, we sort of factor things out. We'll get... so we can pull out the factor of 1,000 plus 100 plus 10 plus 1. Then we can pull out a 6 from each of these and then get A plus B plus C plus D. Okay. So what makes an n the value is not all that weird. It's just 6,666 times a plus b plus c plus d. That's it. That's all the n's look like. Okay, well, I can factor some of this. Now, we want the distinct prime factors, so we don't want repeats or anything like that. At least that's the way I'm reading the question. Now, we can already factor the 6,666 into prime factors. And then it's just a question of the prime factors of a plus b plus c plus d. Right, so we get a 2, a 3, and then what are we left with? 1,111. Well, you can take out a factor of 11, and that'll leave you a 101, and that's a prime number as well. So we get that times, what are the prime factors involving a plus b plus c plus d? And we don't want repeats or anything like that, so we could try something like, well, if we want big prime factors, we might try 9, 8, 7, 6, but that's going to be 13, 17, that's going to be 30, and that'll share a factor with 2. And it also have a factor of 3. Now, that doesn't mean we can't do that, but let's put that sort of on the off to the side for a moment, see if we can do better. Because that would be 2 times 3 times 11 times 101 times 5, if I'm reading their distinct prime factors correctly. Okay. What would be nice would be something like, well, 30 is kind of close to 29. 29 is a pretty big prime. Now, 2 plus 3 plus 5, that's 10, plus 11 is 21, plus 101 would be 122. Is 122 one of the listed possibilities? It's not even listed as a possibility, so they automatically assume we're going to go past that. Unless, is 127 listed? 127 is listed, so maybe I'm misreading this sum of distinct prime factors. I don't think I am. But what if we tried something like 9 plus 8 plus 7 plus 6 for my a plus b plus c plus d? Or, not 6, 5. Silly me. Right? Because that's going to be 29. And then we're going to have 2 plus 3 plus 11 plus 101 plus 29. The 101 and the 29 make 130. So we have 130 here, and then we have 16 here. That's going to be a sum of 146, and I really don't think we can do better than that. Is 146 a possibility? It is. It's D. Now, there are two numbers that are bigger. So either we've missed something, or we should probably at least be comfortable with this before we move on. So let's think about this. A plus B plus C plus D, they have to be distinct, right? So at most you could have 9, 8, 7, 6. So at most you could have 30. Okay? Now, no matter what number you choose, it might break up into other primes. Now, 29 just breaks down into itself. So would something like 23. But how do we know 28 won't do better? Or something else? You might say something like 16, because that's got a 13 in it. And so we could say, well, all right, you could have 30, you could have 29, 28, 27. What are the prime factors here? Well, this is just a bunch of 3s. We've already got a 3, so who cares? 26, well, that would be a 2 and a 13. Well, the 2 is not going to do anything. So we're adding 13, or we're adding 29. You're definitely going to do the 29. Here with the 30, we only added the 5. For 28, you'll have 2 2s. Won't count either of those. And then a 7. Adding a 7 versus adding a 29, of course you're going to add the 29. And we can reason like that and get 146, and we can be pretty confident in our answer from there. So that's going to be an answer of C, and that's where I'm going to leave question 24. We've got one more to go, question 25. I will see you for that in the next video. Until then, have a wonderful day, and take care.